We're going to graph cotangent the same way we graph tangent. So we're going to use the same key points and zooming in a little bit. Keep in mind cotangent is the reciprocal of tangent. So instead of sine over cosine, it's actually better to think of it as cosine over sine. So we'll do the same thing. We'll pick certain values, and the reason I'm picking these values is these are the ones that help us see the graph the clearest. So let's start with 0 this time instead of negative pi over 2 like we did with tangent. Cosine of 0 is 1, and sine of 0 is 0. So at 0, what we actually get for cotangent is we see that it's undefined. So at 0, there's going to be this vertical asymptote for cotangent. Pi over 4, cosine of pi over 4 is rad 2 over 2, and sine of pi over 4 is also rad 2 over 2. So in this situation, cotangent of pi over 4 is 1. So I'm going to go ahead, pi over 4, comma 1. Pi over 2, so cosine of pi over 2 is 0, and it doesn't really matter what sine is because 0 over anything is going to be 0. It turns out that sine is 1, so 0 over 1 is still 0, so pi over 2 I'm going to plot 0. 3 pi over 4 is in the second quadrant. Cosine in the second quadrant is negative because cosine is the x-coordinate on the unit circle, so it's negative rad 2 over 2. Sine is positive rad 2 over 2, and so 3 pi over 4 cotangent is negative 1. Okay, and at pi, lastly, cosine of pi is negative 1, and sine of pi is 0. So at pi, we get undefined, which we now know is a vertical asymptote. So the graph of cotangent looks like x cubed, and actually looks a lot like tangent if it were reflected and shifted over a little bit. And just like all the other trig graphs, cotangent also repeats. So if you think about how it looks if it were to repeat, it would do this. And just like tangent, the period is not 2 pi, the period is only pi, and there is no amplitude because the graph doesn't have a top or a bottom, it actually keeps going.